Alright, so we're looking at how to evaluate logarithmic expressions now. So what I'll talk about first is how to convert between exponential and logarithmic equations. So if I've got an exponential equation, I can convert it to a logarithmic equation. I use the acronym BEN. So B stands for base of the exponential, E stands for exponent, and N is just the other number. So in this case, if I've got 2 to the x equals 16, I can see that 2 is B, x is the E, and N is the 16 is the N. So what I'm going to do is convert this over to logarithmic form, and some things are just going to move around. So the base of the exponential becomes the base of the logarithm, the exponent goes to the other side of the equal sign, and the N is the number that you're taking the log of. So when I convert this to logarithmic form, I can see that I've got log. So the base of the exponential becomes the base of the logarithm. Okay. I can see that the E, the exponent, goes to the other side of the equal sign, so the exponent goes to the other side of the equal sign, and the 16 comes down here. Okay. Or I could be given the logarithmic form and need to write it as an exponential form. So in that case, I still follow the same trick. So this would be my base, my B. This is my N, this is my E. So I can see that base of the logarithm becomes base of the exponential. Base of the logarithm is 5, so that's 5. This is my exponent here, so it's 5 to the x equals 25. And that's that equation written in exponential form. Okay? Now, if I'm trying to evaluate logarithmic expressions, I can use this trick to my advantage. Let's say I want to evaluate log base 3 of 9. Well, what I would do is first of all set it equal to x, because I'm trying to find out what it's equal to, and now I'm going to convert it into exponential form. So this is my B, this is my N, this is my E. I'm going to write it as BE equals N. So this is going to be 3, this is my exponent, is x, equals 9. Now I try to write exponentials on both sides that have the same base. So I can see that 9 can actually be written as 3 squared, right? So I can say that 3 to the x is equal to 3 to the 2. Since left-hand side equals right-hand side and the bases are the same, that means the exponents must be equal as well. So this tells me that x actually must be 2 in this case. Okay, let's do another one. How about log base 2 of 16? Okay, so I'll convert it into exponential form first. I know that this is B, this is N, this is E. So my base of my logarithm is 2, my exponent is x, and the number that goes to the other side is 16. So I've got 2 to the x equals 16. I need to try to write exponentials with the same base. 16, well, I need to try to write it with a base 2 at this point. So I know that 2 squared is equal to 4. 2 cubed, will multiply by 4 by 2, gives me 8. 2 to the 4, keep multiplying by 2, would give me 16, right? So I can see that 2 exponent 4 is equal to 16. So with that in mind, I can rewrite this as 2 to the 4. Since my bases are the same, I can say that x must be equal to 4. Okay? How about one more example? How about if I had the log base 3 of 1 over 27? Okay? So I'm trying to evaluate it, so I'll set it equal to x to find out what this is equal to. I will convert it into exponential form. This is my B, this is my N. Don't worry that it's a fraction. This is my E. Okay? So I'm going to write it in B, E, N form. So the base is 3, my exponent is x, my N is 1 over 27. Now, hopefully remember that 3 to the 3 is equal to 27. So that means I could write 3 to the negative 3 as 1 over 27. Okay? So what I can do then is that 1 over 27 is equal to 3 to the negative 3 using my negative exponents. So x must be equal to negative 3.